let's look at a few examples at converting rectangular equations into polar equations. And then usually if possible, we want to solve for r. So to do this, again, there are four conversion equations that we can use, and they're the same equations that we saw when we converted from coordinates from polar to rectangular or rectangular to polar. So we know that x is equal to r cosine of theta, and y is equal to r sine of theta. We also have r squared is equal to x squared plus y squared, and then we have the tangent of theta is equal to y over x. And again, all four of these come just from our understanding of right triangle trig. Okay, so if I have a point in the xy plane, an x and y coordinate, that means we could create this right triangle where the horizontal distance is x, the vertical side is y, and then the diagonal distance would be represented by r. So that's our hypotenuse, and we want to find the acute angle inside there. So that would be our theta. So again, x is related to theta using cosine. So x over r would be cosine of theta. Y over r would be sine of theta. X squared plus y squared equals r squared. That's the Pythagorean theorem. And then y over x would be tangent of theta. So it's all just right triangle trig. And then we're just kind of rewriting it using x's and y's and r's and thetas. Okay, so that's where these four equations come from. So for our first example, we want to rewrite the equation 4x plus 7y equals 2. Okay, so 4x plus 7y is equal to 2. If you remember your pre-calc algebra, that's just a linear equation. And so if we want to express that, convert it in polar form, we need to replace the x's and y's with r's and thetas. So that's the basic idea. Can we replace any x with an r cosine of theta, any y with an r sine of theta? So we want to get rid of x's and y's and only have r's and thetas. So I'm going to take the 4x and I'm going to replace the x. So I'm going to have 4r cosine theta plus 7, and in place of that y, I'm going to have an r sine theta, and that's still equal to 2. So 4r cosine theta plus 7r sine of theta is equal to 2. So as far as converting from rectangular to polar, we've actually already done that. Okay, we have now expressed that 4x plus 7y equals 2 as a polar equation. Okay, we've eliminated the x's and y's and converted them to r's and r's and thetas. But usually we also like to, if possible, solve it for r. Normally when we have rectangular equations, we like to solve them for y. So we have y equals something with x's. We typically like to try, if possible, to do the same thing with polar, where we're going to solve it for r. So we'd like to have a format where we have r equals some expression containing thetas. Okay. So again, we are actually in polar form now with the 4r cosine theta plus 7r sine of theta equals 2. That is in polar form. We just want to solve it for r now. So to do that, notice that both of our terms have an r in them, so we could factor that out. So we're going to have we're going to have r times the quantity 4 cosine theta plus 7 sine theta, and that is equal to 2. And then to isolate the r, we can just divide that whole quantity inside of parentheses over. So r is going to equal 2 divided by the quantity 4 cosine of theta plus 7 sine theta. And so that's what our polar equation looks like that would correspond to that linear equation 4x plus 7y equals 2. All right, let's try another one. This time we have y is equal to 1/2 x squared. Hopefully you can recognize this as being a parabola. It would be a parabola with its vertex at the origin opening upwards. The 1/2 just scales it vertically by a factor of 2. It compresses it by a factor of 2. So how would we convert this rectangular equation into a polar equation? Well, we do the same thing. So we're going to replace the x with r cosine theta and then the y with r sine theta. So in place of that y, we're going to have r sine theta. And that is now going to equal 1/2 times r squared cosine squared theta. All right, and the r cosine has to get squared because it's x squared. So that's why it's r squared and cosine squared. So we have technically converted this now into our polar coordinates. We just want to go ahead and solve it for r. So there's a couple ways we could try to do this. You can, so there's some sort of hand waving that goes on here sometimes with these polar equations. You might be tempted just to divide both sides by r, and we can do that. But you always have to be careful whenever you divide by a variable. You could potentially be dividing by 0, and doing so ends up eliminating part of your answer or part of your solution. So we want to be careful doing that. If we did that, we would have, so r sine of theta divided by r would just result in sine of theta. And 1/2 r squared cosine squared divided by r would just give us 1/2 r cosine squared theta. And so there's only one r left in our equation. So if you wanted to isolate it, you could multiply both sides by 2 and then divide the cosine squared. So you would get 2 sine theta divided by cosine squared theta, and that's equal to r. Okay, so that works. But technically, we have sort of eliminated a potential value here. Let me show you an alternate method of doing this. So instead of just dividing the r, usually what we want to try and do in this situation is to subtract one term. So anything on one side of the equation, we want to subtract it over to the other side, set it equal to 0, and then factor. So if I do that, this time let's take r sine theta equals 1/2 r squared cosine squared theta. Let's subtract this r sine of theta from both sides. And so on the left side, I'm going to be left with 0. So we're going to have 0 equals 1/2 r squared cosine squared theta minus r sine theta. And so our two terms, I have an r squared with the cosine, and then I have an r with the sine. So I could actually factor in a single r out of both of those. So if I pull an r out, I'm going to be left with r times the quantity 1/2 r cosine squared theta minus sine theta. And then using our property where if you multiply two things and you get 0, then that means that either r is equal to 0 or 1/2 r cosine squared theta minus sine theta is equal to 0. And if we take the second equation and solve it for r, we get the same thing we had before. We're going to have 2 sine theta over cosine squared theta. So doing it this way, we actually do get two solutions. We get the same one that we had before, r equals 2 sine theta over cosine squared theta, but we also get r equals 0. And so that means when we did it the first way, when we divided both sides by r, we're actually dividing both sides by 0, which usually we don't like to do because it's undefined. But it also resulted in us losing this r equals 0 solution. Most of the time, we just ignore this r equals 0 solution. There are various reasons why. Depends on the context that you're talking about. Usually most textbooks just ignore that, and so they would just say that the r equals 2 sine theta over cosine squared theta would be the correct equation. We could actually verify this if you were to graph r equals 2 sine theta over cosine squared theta on a polar plane and compare it to the graph of our original function, y equals 1/2 x squared. They actually do produce the same graph. Okay, so just visually we can graph them and verify that that the r equals 0 solution is not necessary. And really, the r equals 0 solution, it really is just a circle of radius 0. So it's really just a point at the origin. And another way that we can kind of reason through that we don't need to include this as a secondary solution is if I were to plug, say, 0 in for theta into my 2 sine theta over cosine squared theta. If I put 0 in for the theta, so 2 sine of 0 over the cosine squared of 0, well, sine of 0 is 0. So 2 times 0 is 0. And then cosine of 0 is a 1, and 1 squared is a 1. So that ends up giving me the fraction 0 over 1, which is, in fact, 0. So the r equals 0 solution I actually get in my other function, my other equation. So we can kind of just, it's a secondary solution that's already included in the main one that we want. So either way, again, there's just various things that we can think through, but we don't actually need that r equals 0 solution. So we can just say that y equals 1/2 x squared is equivalent to the polar equation r equals 2 sine theta over cosine squared theta. All right, let's look at one more. This time we have x squared plus y squared minus 2y is equal to 0. So right off the bat, I see x squared plus y squared. And so we could use x equals r cosine of theta and y equals r sine theta. But instead, I already have an equation to convert x squared plus y squared. I know that is equal to r squared. So x squared plus y squared minus 2y is equal to 0 could be rewritten as r squared minus 2 r sine theta is equal to 0. So again, I'm using the x squared plus y squared equals r squared, and then I'm using y is equal to r sine theta. Okay, so again, to go from here, again, we kind of have two methods that we could do this. One option would be to add the 2r to the other side. So we have r squared is equal to 2r sine theta, and then divide an r into both sides. So you get r is equal to 2 sine theta. Or, again, there we have to deal with what happens if we're dividing, if r equals 0 is a solution and we're dividing by 0. Or we could worry about that and factor instead. So r squared minus 2r sine theta, we could factor an r out, and you'd be left with r times the quantity r minus 2 sine of theta. And again, because we're multiplying two things and getting 0, that means I can say r is 0 or r minus 2 sine theta is 0, which means r is equal to 2 sine theta. So just like we saw in the previous example, I end up getting two possible solutions, r equals 2 sine theta or r equals 0. But again, the r equals 0, that will already be included in the 2 sine theta equation whenever theta is 0 or pi or 2 pi and so forth, right? So this r equals 0 is just kind of a redundant solution, and we can just go ahead and ignore it. And so we can say that x squared plus y squared minus 2y equals 0 can be rewritten in polar form as r equals 2 sine of theta. And if you were to graph both of these, one in polar and the other in rectangular form, their graphs do actually match up. So it is equivalent.